Today we are going to talk about Gaussian formula. We will start from his story first. Gauss is a German astronomer, physicist, and mathematician. He is one of the greatest mathematicians in human history. With Newton and Archimedes. He was born in April 13th, 1777 in Brunswick, and unfortunately died in 1855. He was born in a poor family. He was funded by a noble to go to the university. At first, he went to the University of Göttingen in 1795 to 1798, and after that, he went to the University of Helmstedt in 1807 and got the doctorate because of algebra basic theorem. When he was 7 years old, his father sent him to the primary school. And after that, teachers found his great talent in math. After he was 10 years old, his teacher made a difficult question for students to do, which is to find the sum of number 1 to 100, and Gauss found that was quite easy, and he solved the question immediately after the teacher gave out the question. The teacher thought Gauss was doing prank on him, but after then, he realized Gauss is the only student in class who got the correct answer. He was surprised that Gauss told him, "I found when first number 1 plus the last number 100 is 101, and the second number 2 plus the number before the last number, the number 99, is also 101. And there are 50 pairs of these kinds of combination. So the answer should be 101 times 50 is 5050. That's the story of Gauss, which he found the Gaussian formula. Now we will discuss arithmetic and geometric progressions.
Hello, my name is Jack. Now I'm going to introduce a math sequence called arithmetic progressions. First, arithmetic series goes from one term to the next by adding or subtracting a common value. Here is an example: 3, 11, 19, 27, and 35. The first term 3, we can call it A, and we all got the same difference between each number, which is 8. So we call it common difference. Then we can know that the third term is the first term A adding 2D, which is A plus 2D. So the first term is the third term by adding one more D, which is A plus 3D. Then we can get a conclusion, which is n equal to A plus n minus 1 times D. So here is the question. We can know that the first term is 5, so A equal to 5, and the common difference is 2, so D equal to 2. So let's use the equation A plus n minus 1 times D. We can know that 17th term equal to 5 plus 17th minus 1 times 2, which is 37. Then I will introduce an advanced knowledge called the sum of an arithmetic series. We can know that Sn equal to a plus d, and we keep doing that till to the last term. And let's write it in reverse way. If we add these two equations together, then the most magical things happen. We can know that 2Sn equal to infinite a plus l plus together. So we can know that 2Sn equal to n times a plus l. If we move to 2 to another side, we can get Sn equal to 1 over 2 times n times a plus l. So if we let L equation a plus n minus 1 times d to that equation we just got, we can get this. Here is a question. 1 is the first term, and we all got a common difference 2, and it's 50 terms. If we put all those things in this equation, we can get the sum of 50 terms is equal to 2,500. Here is another equation. We know the last term, so we put it into the last term equation. We can get n equal to 41. Then we put it into the equation. We can know the sum of 41 terms, which is equal to 2091. Here is a real life application. We can know that the stairs is just like arithmetic sequence. They all got a common difference 5, so we can go up and down stairs. It will be right like this. Thank you for watching.
Hi guys, my name is Shirendra and I'm here to talk about geometric progressions. Geometric progression is like an arithmetic progression, except it does not have a common difference. Although the first term is still denoted as a, it has a common ratio, which is a multiple of the term beside it. Here we can see the common ratio is 3, and we can denote that terms go by this format. And the n term would be ar to the power n minus 1. Here we see in this example, here's an example question. Find the 10th and 20th terms of a geometric progression where the first term is 3 and the common ratio is 2. Here we just apply the formula. Ar to the power n minus 1, you substitute the values, it becomes 1536 for the 10th term, and for the 20th term you use the same method. Now we're going to explain the sum of a geometric series. Here we can show that the terms accumulated go by this form. Here's a simple method to obtain the formula. You multiply all the terms by r, so you obtain this. Rsn equals this sequence, and then you subtract the second by the first, and then you obtain Sn minus Rsn equals a, and this eventually becomes Sn bracket 1 minus r equals a 1 minus r to the power n. So you divide both by 1 minus r, and this is how you obtain the sum of geometric series formula. And you have to make sure that the ratio does not equal to 1. Here's an example question to find the sum of a geometric series with 5 terms. Here we can denote that a equals 8, n is 5, and the ratio r is minus half. All we have to do in this question is just apply the formula. Then we obtain that the sum of the geometric series of these 5 terms is 11 over 2. Here is a slight variation to the other questions where you have to find the number of terms in a sequence where the nth term, a and r are given. Here we can denote that 64 is 2 to the power n minus 1 and 64 is 2 to the power 6. Since both bases are equal, we can equate the powers. So 2 to n minus 1 equals 6. So n becomes 7. Here we're going to talk about the sum to infinity. Here, using the sum of a geometric series, we can show that when r reaches 0, n increases. Therefore, we can denote that the sum to infinity's formula is a over 1 minus r. Let's take an example. Find the sum to infinity of a geometric progression with the first term 3 and common ratio half. Here we just need to apply the formula where a is 3 and r is half. So 3 over half is 6. Let's have a slight variation where the sum to infinity is 4 times the first term. Here we can denote that S infinity is 4a. Therefore 4a equals a over 1 minus r. Here we can switch the sides. So 1 minus r becomes a quarter. And r becomes 5 over 4. Some practical applications of geometric series would be testing the effects of a new vaccine by monitoring the bacteria count or calculating the increment at the end of the month. Thank you for listening.